Okay, hello everyone. So can you hear me? Hello. Okay,
You are
so
in mute, bro.
okay, thank you. Okay, so now can you hear me? Yeah.
Yes, bro.
Okay. Now we'll start our today's class. Message in our group.
Next class and next Friday and Saturday, bro.
Yeah, only for the Friday and Saturday a week.
Okay, thank you. Okay.
So basically, when you can get time, they can. In the meantime, you can also practice and also face any problem. We can also discuss in our WhatsApp group. So basically, a lot of things as a beginners, a lot of new things will be come in here. That's why you also need times for your practice. So you can take the class only for the 2 days.
Okay, thank you.
Okay, so now we'll start our today's class. Now can you see my screen?
Yes.
Okay, so hi and welcome the 7 days online training program on Google Earth Engine for remote sensing analysis. Previously, we also tried to discuss about the some basic things in Google Earth Engine platform, how it will be work, how we can easily import the shapefile. Okay, so basically in this time, first of all, I will try to discuss our today's class 2 hours. After completing this at 2 hours, we can then move to our problem solving class for the another 1 hours. Okay, so let's go. Okay, so basically this is our 2 days. So second day's class content, I will try to discuss about that how we can easily filtering and the displaying the satellite images such as Landsat or Sentinel. How can easily do this? Suppose any region, any time period, or how can easily do this? Display the satellite image or Landsat image. How can easily do this? After this, how can easily use the different types of band combination? Okay, then how can easily export the satellite images? I will also try to discuss about that. We also try to discuss about that how can easily import, filter, reduce, clip, and display data in Google Earth Engine platform. Then we also try to discuss about the time series chart. How can you make the time series chart for the NDVI? How to export the any shape file and calculate the any indices from the satellite images. Okay. So let's go. So first of all, Earth Engine public data catalog. So it's the totally public data catalog. From this public data catalog, we can get lot of remote sense data. So Landsat, Sentinel, MODIS, train, land cover, atmospheric data, or more on the way. And this data set is daily updating. Okay. In this data set, you can find out more than 200 public data set, more than 4,000 new images every single day it produce. You can get the 5 petabytes of data or more than 5 million of images we can get from this Earth Engine public data catalog. We can easily go to the Earth Engine public data catalog from this link, or if you want, you can simply open your code editor. I simply open my new code editor. You can also access the Earth Engine public data catalog from this code editor. In this code editor, here you can see the top of the code editor. Here you can see the search bar. I can simply click the search bar. You can see browse data catalog. When I click on the browse data catalog, here I can get all of the Earth Engine public data catalog. Okay, so all of the data set I can get from this link. So here you can see the different types of data such as surface temperature, climate, weather, atmospheric, different types of imagery, sentinel, MODIS. Also you can see land cover data set, train data set, proplan data set. Lot of data set is available, and this data set is the daily updating automatically added in here. And this data set, suppose you can see Landsat. In this time you can get all of the Landsat image collection such as Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5 MMS. We can get all of the Landsat image collection in here. I simply click on the Sentinel. So now I can get all of the Sentinel image collection such as Sentinel 1, Sentinel 2, Sentinel 3, Sentinel 5. Okay. Also you can see this data set, derivative data set such as you can see world cover, dynamic world. We can get also from this Sentinel 2 satellite image. Basically in this time you can see this is a ready-made data set. This data set is the combination of the Sentinel 1 and Sentinel 2, and they are make the data set for the land use land cover classification for the whole world. Same for the dynamic world data set also. In this time, when you use the data set for this type of data set, you don't need to use any machine learning method. You don't need to use anything because this data set is already created. Okay, just I can simply click and get the result. But when you want to work with the Sentinel 1, Sentinel 2 multispectral instrument or Landsat imagery, then you also need to apply the different types of machine learning method and then make the land use land cover classification map. Okay, so which data set is already available or created, we don't need to use any types of machine learning or any types of algorithm. We don't need to it. Just we should know how we can import the data set, how I can get the layer, how can easily export the data set, all of the things. But when I want to work with the Landsat Sentinel for the land use land cover classification map, then you also need to know the lot of process. Okay, lot of algorithm such as supervised algorithm. You need to take the training point. You need to apply the different types of machine learning such as classification, regression trace, also support vector machine, then minimum distance. Lot of classifier is available for the supervised machine learning method. So in this time also you can see the MODIS, another data set. So this MODIS data set mainly here you can get all of the MODIS product, daily MODIS product. You can see there are a lot of data set. MODIS Albedo daily, MODIS BRDF Albedo quality daily, Terra surface reflectance daily, Terra snow cover daily, MODIS land surface temperature we can get. Also you can see Terra surface reflectance daily. So there are the lot of data set for the MODIS. Also you can see MODIS deep area index data set, Terra surface. So lot of data set we can get. Also you can see land surface temperature 8-day global. So all of the data set for the MODIS we can get in here. Okay. So in this time, I just try to show you only one data set, how you can easily import, how you can easily filter, how you can easily get the result. Okay. But you are also try to for all of the data set, the same process when you want to apply. Okay. Okay. Anyone any question? Yeah, please. Please. Yeah.
Hi, this is Abdul.
Yeah.
Rahman, I just wanted to ask one thing. These are the satellite images. How about synthetic aperture radar and microwave? Do we have this kind of data also available here?
Yeah.
SAR and microwave related?
Yeah. It's also available. We can easily get the SAR data from the Sentinel-1 data set also.
Okay, and it is processed and it is already pre-processed everything, right?
Yeah.
Okay, thank you.
Okay.
Great.
Yeah. So in this time, you can see there is a lot of data set for the modis. So all of the data set for importing, for creating the map, for export the map, all of the things will be same. Okay. In this time, I just show you only for the one data set, and you also try to for your own self for all of the data set. Okay. So in this time, I try to show you the one data set is that I want to show you the data set for NDVI. So I want to work with the data set for the, you can see there are vegetation indices 60-day global 250-meter resolution. This data set I want to use. It is a totally modis data set, and this modis data set I can simply open the data set in here. Okay. So now you can see I can get the data set for the modis. Okay, this data set I want to get the modis, and here I can get all of the data set availability date. You can see we can get the data set from 2022. This is a data set provider. Also, you can see Art Engine snippet. Basically, this Art Engine snippet is the unique ID. All of the data set. It can be Lancet, it can be Sentinel, it can be Modis. All of the data set has the unique ID. Okay. This is the unique ID, and unique ID is the different from the one dataset to the another dataset. So this dataset unique ID is that Art Engine snippet. So this is the unique ID for the modis that are visiting indices 60-day global. This dataset for this unique ID. Okay. Also, you can see this dataset resolution 250-meter resolution. This dataset provide you the two band NDVI and EVI. NDVI is the normalized difference vegetation index, and EVI is the enhanced vegetation index. So if you want to know the more details about the NDVI and EVI, you can simply search on the Google. There are a lot of article. You can, I hope you can easily understand what is the NDVI or what is the EVI. Okay. So in this time, I just show you that how you can easily use the data set and make the NDVI map or normalized difference vegetation index map for any region. Okay. Using the Google Earth Engine platform and use this data set. Okay. So first of all, you have to import the data set. This is my data set. This data set I need to import in my code editor. This is my code editor. I need to import. I can import the data set in the two way. I try to show you the both of way. So first of all, you can see, if you want, you can simply search here. Search modis NDVI. Here you can see I use the data set modis vegetation indices 60-day global 250-meter resolution. This data set. I simply click here. Here I can get all of the same information. Which information I want to get in here. I can get the same information also. All of the things will be same. Okay. All of the things will be same. Also, you can see band. All of the things will be same. Okay. If you want, you can simply click the import. This data set will be imported. Okay. Here you can see the image collection. This is the default variable name. So in this time, my data set is imported in my code editor. Okay. It's a only one way. Another way is that if you want, you can simply copy. You can see, simply copy this Art Engine snippet from here. I simply copy it and then paste in my code editor. Okay. After paste, I can simply take a variable name. Suppose this variable name is that modis. You can use any variable name, no problem. Modis NDVI. Okay. So now you can see this is my image collection of the modis. Now it is stored in this variable. So now this data is the imported. You can use any one way, no problem. Okay. So if you want, you can simply import, or you can simply copy the Art Engine snippet from here and paste here and give a variable name. All of the things will be the same way. So in this time, I simply remove it. I want to use this way and import my dataset. So I can see all of the dataset. When you want to import on your code editor, you can just follow this process. Okay. You can simply import from this here, or if you want, you can simply copy this Art Engine snippet from here and give a variable name. And after before the variable name must be used at the var keyword. In this time, my full image collection is stored in a variable. This variable name is the modis NDVI. Okay. Okay. In this time, you can see this data set has a two band, NDVI band and EVI band. I want to work with the NDVI. Okay. So that's why you need to select the band. Okay. So in this time, I just simply take the another variable. So I simply put the variable name, suppose. I can simply put the variable name NDVI. Is any variable name. Okay. In this time, you can see this image collection is stored in a variable. This variable name is the modis NDVI. I simply copy this variable name and paste here. Because this variable is stored two band. Okay. It's full image collection. Okay. from this full image collection, I want to work with the NDVI. So that's why I need to select only for the NDVI. So I simply use a function. It's called the select function. Select my band name is that NDVI. Okay. So what happen, you can see. First of all, this is my full image collection. Full image collection means that it has the all of the band is available. But in this time, I want to work with the NDVI. So that's why I simply call this full image collection variable name. From this, I want to select only for the NDVI band. Okay. And all of the things will be stored at the variable name NDVI. You can use any variable name, no problem. Okay. So in this time, I want to check how many NDVI images are available for the whole world between the time period year of 2000 to present time 2022. This time period, how many images are available? I want to check it for the whole world. Okay. So for this, I can simply add the print function. I want to print it. This yellow. I simply print, and then I simply call this variable name NDVI and paste here, and use the function size function. Okay. So mainly in this time, in this variable NDVI, how many images are available? I want to check it. So that's why I simply use the size function. Okay. And click to the run. In this time, you can check how many images I want to get. 522 images I want to get for the whole time period, year of 2000 from 2022, between this time period. But in this time, I don't work for the whole time period. I want to work for the any specific year or a specific month or any specific time period. Okay. Suppose in this time, this 522 images between this time period. Okay, between this time period. But I want to work only for the time period for the year of 2015 to 2020. Okay, this time period I want to observe the what is the NDVI condition. Okay, between only for the 5 years, 2015 to 2020. So for this, I can simply take the another variable. I simply take the another variable. Suppose filtered NDVI. You can use any variable name. In this time, you can see 522 images are stored in a variable. What's the variable name? This variable name is the NDVI. I simply call the NDVI and paste here. And then in this time, I want to filter the date. I want to filter the date specific for the specific time period. I need to use a function. This function is the filter date function. Filter date. As a beginners, I don't know what is the argument. I can get the argument start and end. So in this time, I simply put the start date and end date. So I simply put the start date. Suppose year of 2000. Suppose 1st January. 1st January from year of 2020 or 31. Okay. Between this time period, I want to observe the NDVI. Okay. So now I want to check how many images are available between this time period. The same function, I simply use here the print function and then simply call the filter NDVI. I simply copy and paste and use here the size function. Okay. And click to the run. So now I can check. I want to get only 138 images between this time period. Okay. Okay. So in this time, I need to reduce this image collection. So there are a lot of way for reducing. In this time, you can see if you want to print this, I want to check the acquisition time period, or you can I simply print this. You can print the filter NDVI, copy, paste, and click to the run. In this time, you can see I can get all of the image time. So you can see from the feature, you can see first image, 1st January, 17th January, 2nd February. You can see what is the time interval. This interval time is the 16 day. So every image time interval is the 16 day, 16 day, 16 day, 16 day. Okay. So that's why this dataset called the 16 day global. Okay. So in this time, I get the 16 day. Okay. In this time, all of the images, I need to reduce this image collection. Okay. So in this time, I want to calculate it, all of the images mean or average pixel value. All of the images, total 138 images, I want to calculate it the average. Okay. So we can easily do this in here. So I simply take a variable. Suppose I simply put the variable name average. average. Okay? Average NDVI. You can use anything. I simply use average NDVI. In this time, you can see this 138 image is stored in a variable. What is the variable name? Filter NDVI. I simply copy it and paste here and use a function, reduce function. So reduce is a statistical function. So when you want to work with any statistical part, suppose you want to calculate it, the minimum, maximum, standard deviation, average, then we are using the reduce function. Then we need to define how I can reduce. In this time, I want to reduce using the average or mean. So I simply use that the e dot reducer dot mean. Okay. So in this time, all of the images, 138 images, I want to create the average result. And this result is stored in this variable average NDVI. I want to check the result. So I simply the layer map dot add layer, and then I simply call the average NDVI and paste here and click to the run. In this time, we can get the result for average NDVI for the whole world. You can see for the whole world NDVI map we can get. In this time, we can get the ash color map. You can see because I did not add any visualization code or any visualization color code. First class, I also discussed about that. After the object name, we always put here the visualization part. So in this time, I want to simply copy their visualization code in this space. So I simply copy it. I simply copy and then I simply paste here. Simply paste this code in here. In this time, you can see what they are write the code. They are simply take a variable name. They are make a dictionary. In this dictionary, they are put the mean value. It will be start from the 0 pixel and up to 8,000 pixel. And they also make the some color plated look like this. Okay. In this time, I use the same color plated. So in this time, this is the variable name. I simply copy the variable name. After the object name, I simply put the visualization variable name and click to the run. Then I can say I can get the color for the whole world NDVI map. I get created. Okay, so you can see there is a lot of data set total 2015 to 2022. All of the data set for the whole world. I just create the map within 1 second for the whole world NDVI map. Okay. Okay, so this is the process for the whole world NDVI map. We can easily identify where is the dense vegetation, where is the low vegetation. We can easily identify all of the region of the world. In this time, I don't need for the whole world. I need only for my specific region, such as Bangladesh, India, or any more local region. Okay. So for this, you can easily import your shapefile. Okay. So, or if you want, you can also use this boundary from the US dataset because this dataset provide you all of the international country boundary polygon. I simply import this, and then I just simply take my country name, take my country boundary. The variable name is of a country. The same code. This code I already discussed about the previous class. Okay, anyone, any question?
Rahman, just regarding the palette, is it the defined one or we can define our own also?
You can easily change this, no problem. I also try to show you this how you can easily define for your own color plated also. Okay, so it's this code is this color code is already used for this in here, so that's why I simply copy it and that's it. But if you want, you can also use your own color code. Okay, you can simply put your color name. We can easily do it. Okay, so I also try to show you this part, no problem. Anyone any question?
Thank you.
Okay, any question?
Yes, please.
Yeah.
Yes, please. Regarding mine and max, in visualization method, what's the meaning of this mine and max?
In this time, this visualization is not correct. I also try to show you. So I think when you can talk question, when I complete the first all of the things, then you can ask the question. Then it also better. So when I will finish this part, suppose in this time I talk about the NDVI map. So when I just move to the another part, then before this you can ask the question. Otherwise, it's very difficult to answer all of the question. But you can get the answer when I can show my full content. Okay. So in this time, when you want to show the full content, then I hope you can easily got all of the things because I will go to the step by step. Okay. So when I just call you answer the anyone any question, then ask me. You can just note down your question and then ask me later. Okay. So in this time, I simply just use here the filter. I take this. Okay, so in this time you can see I simply take this country boundary of Bangladesh, and in this time I just simply add this. You can see this is my full map, okay, whole world map. But in this time I not need for the whole world, I need only for the country of Bangladesh. And this country boundary Bangladesh is stored in this country variable name. Okay, I simply copy the name, variable name, and I simply use here the click function. Click country. Okay, and click to the run. So now you can see I can get the result only for the Bangladesh. Okay, but in this time it's not focusing, so that's why I also need to use here this dot object and call my object name is the country. Okay, so now I can get the result for the Bangladesh. But this map visualization is not correct, because you can see it look like all of the things will be green. Okay, so this visualization is not good, because in this time I use this visualization. This visualization is the good for the whole world, but in this time it's only for my local region or only for the country. It's not a whole world. In this time we also easily change this color plated, all of the things we can easily change. I also show you later. Just a minute. Suppose in this time we need to the another country. Country name, suppose Saudi Arabia, and click to the run. So now I can get this NDVI map for the Saudi Arabia, because you can see in this time I simply change the country name. I can easily get all of the country NDVI map for the year of 2015 to 2022. Okay. Okay, so you can see this is the map. In this time, this map is a problem. This problem is that a scale. You can see in this time it's showing the mean value. Okay, if you want to check what is the condition of this place NDVI, simply click on the inspector tab and click on here. You can see you can get the result 3534. But we already know about that NDVI index, this value range between -1 to +1. But in this time it's showing this type of value. So this is the problem. So in this time I need to reproject this scale value. So that's why I can get the result -1 to +1, because NDVI index or all of the index we can get the result -1 to +1. Okay, so now the main question is that how I can reproject this scale and get the proper NDVI map. Okay, so let's go. In this time I try to discuss about this. Okay, so basically you can see this data set has a scale. You can see they are already provide the scale value. This is the scale value for the NDVI. Also you can see same scale value for the EVI. So in this time I simply use the scale value, and then I simply reprojected this scale, and I can get the result -1 to +1. Okay, so let's go. So in this time, this is my scale value. This scale value is multiply with all of the images. Okay, here I can get total how many images? 138 images. I need to multiply total 138 images with this scale value 0.001. Okay, in this time if you want to randomly, suppose you can say I can get all of the images. You can see when you want to put one image and multiply 0.001, then to take the another image, it take a time, long time you need. You can see that the 138 images, you need to write the code total 138 line of code, because when you want to work with a single image, suppose you want to, you can see first image, you can simply multiply the first image, then also need to second image, then third image, then fourth image, then fifth image, and up to 138. Okay, so anyone can guess it in this time what I can use for the reuse my code and make it easier to calculate all of the image would multiply with the 0.001. Anyone can guess it? So in this time you can see I need to multiply 0.001 with all of the images. So how we can do this? Okay, so in this time I need to use the function. Previous class I also tried to discuss about that. When you want to work with this, suppose in this time I need to multiply the same value with all of the images. When you want to randomly put one image and one image, it take a long of time. But when you want to just use the function, we can easily do it very quickly. Okay, so in this time we talk about the function and function structure. We are using the same function structure. All of the things will be same, just we multiply with this. Okay, so let's go. So in this time we just create the function. So that's why it can easily multiply all of the images with our scale factor 0.0001, and we can get the reprojected our scale value.